Algebra 2. This is 7.2, Properties of Rational Exponents. So what we're going to do is basically I'm going to give you the properties of exponents again. This is half, the other half's on the next slide. But we're also going to not just use nice numbers as exponents, we're going to kick it up and we're going to use rational or fractions as exponents, maybe even decimals. But we have to realize that the basic properties are still in play here. First one is the product of powers. Again, I'm not going to be too keen on having to force you to name it. I want you to know how to use it. What happens when you multiply two things with the same base? What do you do with their exponents? Add them. So we know that it's going to be a to the m plus n. What's it going to look like now? What it's going to look like now is it's going to be something like a to the 1/2 times a to the 5/2. Now granted, I used common denominators here. Does not have to be a common denominator. If they're not common denominators, in our next step, you would have to get common denominators. So there's all those same types of things when you're adding and subtracting fractions, all apply here. So what's this going to look like? Our next step, make sure we're showing work. What would the next step look like? It's going to be a to the 1/2 plus 5/2, right? If I'm going to show my work. Which then becomes, when I add like fractions, or fractions of like terms, it's 6/2, which ends up being a to the 3/1, or just 3. Okay, so the properties still apply. We still can add our exponents, and then we should always simplify. So it's not too bad. What happens when I have a power of a power? You do what? It's a to the power of a power, you multiply. So it's m times n. So an example of this, how about b to the 4th, oh, not 4th, but let's do 3/4 to the 1/2 power as an example. Does b change? No, b doesn't change. Your exponent or base does not change, but it becomes b to the 3/4 times 1/2, right? And how do you multiply fractions? Bottom times bottom and top times. So it's 3/8 done. So b to the 3/8 power. And of course, if these were numbers, we could evaluate sometimes the 8th root and take the 3rd power of it, or vice versa. Next one is a power of a product. There's a power on a product. What happened here? What happened here? Distributes to both. So a to the m, b to the m. So an example of this one is what happens if I had 8m squared to the 1/3 power. So what does this become? 8, not 8 times 1/3, but 8 to the 1/3 power, m to the 2. 2 is a fraction itself, isn't it? 2/1. So it becomes 2/3. I'm going to say we're not done with this one. M to the 2/3 you can be done with, but 8 to the 1/3? What does 8 to the 1/3 really mean? The cubed root of 8, right? Boy, what's the cubed root of 8? We can evaluate that. 2. What times itself 3 times is 8. That's 2. So it's 2m to the 2/3. The next one is negative exponents. We don't like negative exponents. Where does it go?
The bottom.
To the bottom and becomes positive m. Positive exponents. Remember, if it's in the basement already, it can go to the top and become positive, right? So it doesn't matter if it's a negative exponent. Well, what happens if it's like b to the negative 4/3? Not that big of a deal. Now it becomes 1 over b to the 4/3. It just goes, the whole thing goes to the bottom. Remember, only the thing that has the negative exponent on it. So if I put a 4 in front of here, I'm going to change it. If I had a 4 here, then this becomes a 4 on top, right? The 4 doesn't move. Just the one that has a negative exponent on it. Next one is the quotient of powers. Quotient of powers. What do you do to your exponents when you're dividing? What do you do to the exponents?
You subtract.
Subtract them. M minus n. So in this case, what if I did c to the 3/2 divided by c to the 1/3?
So it would be c.
So become c.
Wait, do you put it as like
We're going to show our work.
Okay.
So we have to do c to the
3 over 2 minus
minus 1/3.
But then how would you put it back into?
You have to get a common denominator.
Okay.
So the common denominator between 2 and 3 is a 6. So that means I had to multiply 2 by 3. Whatever you do to the bottom, you do to the top. Over on the 3, I'd have to multiply that by 2. So our problem is c to the 3 times 3?
9.
9 over 6, right? Minus?
Minus
2/6. And now we have a common denominator of 6, and 9 minus 2 is 7. So it's not that bad. Take it one step at a time. Everything's going to be fine. What happens if you have a power of a quotient, power of a fraction? If you have a power of a fraction, it becomes what? What happens to the last one?
Is that an A?
That's an A over B.
A to the M over B to the M?
Yeah, AM over BM. And so if I had something like 2 over h to the 5th to the 1/2 power. Should be all good. It's 2 to the 1/2 power over h to the 5/2. So the last thing I'm going to leave you guys with is simplifying cubed roots or radicals. Square roots, cubed roots, 4th roots, 6th roots, doesn't matter. Remember, the number that's in front here is the gatekeeper, the bouncer, the one that can't leave home unless you have that many people in your group. And so you need to take 125 and y to the 6 and make trees. You need to break them down to their prime factorizations. And so to do this, I'm just going to start here at 125. It ends in a 5, so you know it's divisible by 5. 125 is 5 divided by, or times, 5 times 25. And then 25 is 5 and 5. What is y to the 6? What does y to the 6 really mean? What does y to the 6 really mean? it's y how many times? 6 times. So you don't necessarily need to make a tree for those, you just need to write them out. And so remember, we put 5 times 5 times 5, and then 1, 2, 3, 4, 5, 6. And then you start to make your partners or your groups. And they have to be groups of 3. There's a group of 3. There's a group of 3. And there's a group of 3, correct? That means, is anybody left home? No one's left home. Therefore, the whole cubed root will disappear. And remember, as they leave, they become just a member of that group. So that's a 5, a y, and a y. And what's 5 times y times y? It's a 5y squared. So you're just going to have to be able to do that. Sometimes it'll be a square root, sometimes it'll be a fourth root. If it's a fourth root, you're looking for parties of 4, right? Now, what it's going to have you do is they're going to put a couple of those together and say simplify it. Like they're going to have a couple of these things with adding and subtracting between them. The only difference between this problem and adding and subtracting them is you simplify everything first, and what you'll do is you'll end up seeing common or like terms that you can add up then. Because you guys should know that the cubed root of x plus the cubed root of x is equal to how many of them? 2 of them. 2 cubed root of x, right? They add up just like any other number, any other variable, and so forth.